Great.
Thank you, Benjamin. Thank you all. I think this is important, making the community grow, and it's a very good opportunity for me to share my experience. I think it was a very long way to came here, but very enriching for me personally and also for my career. As you can see, during the long process of this project, this winning project. About me, in brief, I'm an engineer in computer science. I work for a research institute called CTIC in the north of Spain. We do a lot of things. Well, one of them is Internet of Things, a department in charge of Internet of Things. Also, in the W3C Web of Things working group, not very active, but following all the works, and also promoting the standards. Promoting the standards from the W3C Spain office. This research institute, CTIC, hosts the W3C Spain office to promote the standards in Spain, but also in the Spanish-speaking countries in Latin. So I'm an engineer. I'm a bad programmer. I have quite a few experience in Web of Things. I play with some Arduinos at home. Well, my home is full of cables and Arduinos around. But first of this experience, only a few lines of code and not much experience about the Internet of Things at all. So when I'm here, well, I will explain the full experience from the beginning when I was attending a webinar, a meetup, an online webinar, and when Benjamin told the audience, okay, today is the last day to apply for this challenge, the Open IoT challenge. If you know anything, if you know anyone to submit an application, please let me know and let him know just to do it before tonight. Well, I look at the form. It was a very long day for me at the office at very late. Well, I looked at the instructions. I looked, wow, $20,000. Wow, it's a good opportunity. Without reading much more, I look at the form, the web form. It was easy to fill in. So just 5 minutes, but at the end, I saw I had to submit a video. I record and submit a video. It was a bit scary for me at the beginning. It was very tired, exhausted. Well, at the third attempt, I submitted without any problem at all. Several weeks after that, I received a second or third email from them asking me do you want to keep playing in the game because you are one of the finalists? I think it was the second or third email without any response from my side. I thought it was spam, so I was deleting the email when I realized it was directly to me. So I reply, I say yes, okay, please send me these devices and I will continue with the implementation of this idea. So now what? I started to look at the things I wrote in the form. I wrote something like MQTT, something like standards, but without any idea at all. But the idea, I think it was more or less good. My project was called Active IoT. I've been discussing with Benjamin that it's a very helpful, it's shit, the name. In just 5 minutes, I tried to look for a sexy name, mixing activity, active IoT, so you can see the link, but I hate it as well. So my project was about athletics. I like athletics. I'm a runner. I do it every day. And I like competing. I like the competitions. If you are, well, maybe you do jogging every morning and you take part in those competitions every along the year. You see many people around also running and doing jogging. And figures are amazing. So many people are running around the world, and you can see even the figures in some countries in Europe, like Denmark and Germany. The percentage of the population running, the 31% of the population in Denmark are considered as runners. They take part in competitions every year. So this is a part of the market, of the industry, that we should explore and we should take into account. And if you take part in some competitions, you are aware of these fully automatic timekeeping systems using some RFID tags or chips on your shoes. But they are very reliable. They are you have the results in real time, and it's they are very good and very solid solutions already existing. But for those small clubs or some organizations that want to organize new competitions or raise some funds for some purpose, it's quite expensive for the cost of installing these timekeeping systems or renting the devices or just hiring the services for to those companies. So this is a good idea, but not very. It's expensive. And some other challenges we have seen in this video is well represented. You can see here it's just a competition, a cross-country competition in Kenya, where most of those athletes are the best of the world. Any one of them are much faster than we are here in the Western countries. But you will see at the end, you see they were big numbers, but you will see here in the finish line how they will collect their times and the position. They are given a piece of paper with the position, and after that you can see a kind of funnel. They follow a queue there, and you can see here how they collect all times and all the position of those runners. And those runners are the best of the world. So we can do more things for improving these challenges we see. The cost of these fully automatic timekeeping systems and helping others to organize and organize races and collecting the information and producing also open and standard results using open and standard formats. My proposal was following these foundations, low-cost system, device independent. It should be plug and play more or less. And as I told you, producing open data results and open data information about competitions, about the athletes, etc. It is based on two main components. First of all, runners for sure, wearing a bib number, and maybe we can use this component I told you, the RFID tags, to be read by RFID readers and antennas. Those runners must go through virtual gates, let's say checkpoints along the course. We can install one or n checkpoints. At least we need the final one in the finish line. And the good thing and the most important thing, the cornerstone of the project is MQTT. We use MQTT, or I use MQTT to create those checkpoints and to send the information collected by the checkpoints, the ID of the competitor. Let's say the ID could be the RFID tag identifier or the bib number of the competitor, and the timestamp where this competitor goes through this virtual gate. For this also I use some other standards, some other standard protocols like MTP, the network time protocol, just to be sure that all checkpoints are synchronized. They use the same time. And there is a controller that is the subscriber of the MQTT queue that will collect all the information, and it will process the information, producing results, storing the information in a database, visualizing, and even, as I told you, providing the information as open data using open formats. You can see an example of the kind of message the MQTT sends and receives. A couple of topics. One about the readiness of the checkpoint. Once a checkpoint is ready, it will send a message to the controller, okay, I'm ready. And when an athlete checking in this location, it will produce these kind of topics, information about the checkpoint, the ID of the checkpoint. Even we can send information about the geolocation coordinates, and information about either the VIV identifier or the EPC identifier, which is let's say the identifier of the RFID tag, and for sure the timestamp. To be sure that this competitor went to this virtual gate. This is important. I think it was very straightforward to use MQTT. I configure the queue or the publishers to send using the quality of service one, at least one delivered. I don't mind if I receive many information duplicated or the information duplicated several times. But and after that, well, I will process it using the controller. We had in mind at the beginning this foundation. The checkpoint should be very easy to build and also low cost. So I did a couple of examples using infrared remote control just to type the VIV number of competitor. For sure, this is not very reliable because it's using the infrared, and you must be sure that you are pointed to the reader. But it's just a proof of concept working. And this is more reliable and also working on with a Bluetooth keypad, a very cheap solution, plus a Raspberry Pi. And this volunteer, in this case, typing the VIN number of the competitor, and the Raspberry Pi already connected to the system will timestamp that message. It will send it to the queue. If you have more money, you need a better checkpoint. We can build a RFID checkpoint, more advanced, using, well, a very cheap reader with a simple antenna. This is the proof of concept of this in my kitchen. I'm sorry, it was the most clean part of my room, my flat. I'm sorry, and I tried it, and it was a very good proof of work of this. After implement this, it was a bit hard because I had to learn to program in Python. In Python, I learned not learn, but I was able to manage at least to build this controller of this checkpoint in Python in a weekend. And we try it and we test it in the real life using this kind of small VIV numbers plus touched tag RFID tag just to test it, to check it. And another part of the project is the controller. We have several checkpoints sending information to the queue, and the controller is the subscriber waiting for those messages, the ready messages, and also the checking messages. So the controller is a Meteor application, is a Node.js plus a MongoDB database just to collect the information about the competitors. We don't need too much reliability and too much performance for this. But it worked at the beginning. I will tell you more after this. Well, it's very straightforward and simple, and it worked. My proposal, okay, this timekeeping system for races is low cost, or can be implemented using low cost devices, as you see. It's device independent. As soon as you implement the MQTT subscriber or publisher, that's enough. And plug and play. Okay, it's also the controller will wait for those ready and checking messages. And the last part is open data compliant. I'm trying to follow a new approach we are defining inside W3C to collect information about competitions, about athletics. It's called OpenTrack. OpenTrack is it's more than a vocabulary. We are building also tools to collect and help people to collect information and publish information about athletics. It's based on JSON LD, as Christian mentioned. It's a linked data technology to provide semantics to the web. And we are developing it, and as I told you, it's the objective is publishing the information in open data using semantics and trying to model all the information of athletics, athletes, competitions, results, this kind of information that could be really awesome having it open, available, and we can be able to we will be able to mix and do many things with those with that information. This will solve that the first problem of I showed you with the cross-country competition in Kenya. They collected the information just on a piece of paper. With this kind of information published on the web using common languages, we will be able to mix and to interoperate with all systems and having accurate results from all around the world, not only from our competitions. This is it works. The system produced results in JSON LD, and you can see here just an example how this works. Collecting information about this is describing the race information. This is result from the race. Well, the rank, it starts in 0. And the performance of the competitors. Here is a unique identifier for this competitor. You see here the identifier for the competition, the VIP number, and the transponder identifier or EPC identifier, which is the identifier collected or related to the RFID tag they wear. It seems to be easy, but not so easy. I had many problems to build the system. As I told you, I'm a bad programmer. I'm used to take part in some software projects, but in this area of hardware prototyping and this new concept, it was very hard for me. Many variables on top of the traditional ones, so it was very hard to debug anything. And it was funny because you can find information for everything, and you can find libraries for everything, but they don't work at the first step. You have to dig into it, and you have to do many things. So much more variables to take into account when you start a project of this. One important thing is that the community is key. You can find too many information about everything, and if you need some piece of code, you will find it, with the exception of the RFID reader I bought in China. It only brings drivers for Windows, so I had to code my own drivers for the reader. It was very hard. And one important thing I found, Mosquito, the broker for MQTT, and also the implementations of Paho were very helpful and very straightforward to implement on my prototypes. It was I was lucky for choosing that technology, because I did it just for intuition at the beginning. But I think it was very cool, and thanks to the community, I did it on time. One important thing was the beautiful is not the same as functional. Once I had my system working, I tried to compile everything and create a case, a plastic case, design a plastic case and print it, 3D print it. And after put it all together, this is the RFID reader plus the antenna and a Raspberry Pi. Well, the system, the design was very cool. It was my first design, so I was proud of it. Once I packed everything, it didn't work, because of some fields. Well, at the beginning, the system had a range of 5-6 meters if all the conditions were perfect with the RFID tags. After that, just in the case, only a few centimeters. So it was a it was a shame. But well, it was one of the first lessons learned. Next step of it, I will keep working on it. For sure, I will design another case. I will continue exploring new potential checkpoints. I've been playing with some computer vision tools, trying to check if it is possible to read the VIV numbers automatically as well. Indeed, after that, my boss heard about the project. Oh, you won a project, a challenge, a worldwide challenge. So you must be smart. So, so I was. Now I'm joining in a new project in my company in CTIC. It's a really nice project. I'm learning a lot. It's about. It's a multifunctional toolkit to make energy efficient the old buildings, to convert into smart buildings using IoT technologies, using cutting-edge technologies. So I'm learning a lot here. So maybe we can implement some of those technologies, these open source technologies in the project. Well, I put it this one during your talk. I will join Web of Things Plug Fest, and I hope in the near future I can start working in the WCC working group more actively. I will show you just an example of the controller, how it works. Let me put it here. This is the controller. So you can see here how you can add new checkpoints into the map, on a map. This is just an example. The description, you can add a picture of it, and you place it wherever you will put it into the map. So you can see here the new checkpoint. You can create new races, describing the races, adding pictures, etc. You put a GeoJSON, which is a kind of the course of the description of the course on a map. And you can select the existing checkpoints, indicating the laps to complete for those in this course for those checkpoints. Also assigning the athletes to bib numbers and EPC identifiers. So you can see here the GeoJSON rendered on top of the map and the points, the checkpoints on the map. And this is an example of how a race can be performed. You see the checkpoints changing colors, and as soon as the controller received a ready message with the identifier of the checkpoint, it will change color and it will open this info box. And in the right, you can see in the right-hand side, you can see it's very small, but it's a terminal with the messages received by the controller. And after pressing starting the race, you can see the clock counting. We will see the first athlete appearing there in the first checkpoint. You don't see the information, but it's the position, the name of the competitor, the time, or the gap between the competitor and the previous one. So it's very simple, it's very intuitive, and you can do whatever you want with that information, because you will have this information flowing into the system. You only have to subscribe to the queue, and you can do many things, whatever you want. In this case, we collect the information and we publish it after that using an API, publishing the information, as I told you, in open data, using this new, almost standard to submit information about the competitions. So this is all from my side. Thank you very much for your time. I hope you like it.
So apparently I'm some kind of Nigerian prince. I send emails to people offering money, and sometimes they answer. Thank you. In case that wasn't this is all open source, right? So that's the GitHub repo with.
Yeah, this is everything is available. You can grab all the information. All the code is here. Also, you can take it and play with it. And I think it's well documented. Also, as I told you, you shouldn't rely on all the code there. But it works. At least with this small proof of concept, this pilot, you can try and you can see it works. Do not copy the model of the case for packing the RFID reader, but the rest you can trust on it.
Yeah. Yes. Was there any question? And by the way, I'm not yes, I do like to be the Nigerian prince here, but this was made possible thanks to all our sponsors. We helped put together this challenge. So Intel, CR Wireless, Red Hat, Eurotech, Bit Reactive, and I'm sure I'm missing some. I know this has been a long day, but is there any question for Martin? Actually, it looks like just one.
So I guess I'll throw one out there for you. If you look at RFID and the way the radio waves might propagate, it might be a kind of a spherical waveform from it. So as runners run through, I guess, an area that might not be just a single point, then how do you reconcile with who exactly crossed this notion of a line when? Or do you just try to line it up in such a way that it kind of approximate a line anyway.
Yeah, the idea, well, just this example was, we did it using the, as you saw in the shoulder, and we should to take care the tag should be just in parallel with the reader. Well, it depends on the antenna. We have seen several antennas for a kind of, well, for the ground. Also, we have checked in a kind of gate, but it's still to decide.
So how accurate is the timing? Like up to the second, or?
Yeah, it's up to the second. Yeah.
Okay.
Mm-hmm.
Questions? All right. Thank you again.
Thank you.